Good afternoon, everyone. Today we will be discussing about the sedimentation of coagulation. I hope in the previous classes you have already got the notes on the plain sedimentation as well as the aeration. Now, first of all, we all understand what is the sedimentation from our previous class notes. Sedimentation is a tendency of particles in suspension to settle out of the fluid in which they are entrenched and come to rest against a barrier. The barrier will be like the walls of the fluid container. Now this force there will be to settle the particles like the gravity, centrifugal acceleration, electromagnetism, etc. Also in geology, sedimentation means the opposite of the erosion. That is, in case of the erosion, one particle will move out of the surface, and in case of the sedimentation, the particles will try to settle down under the forces of gravity at the bottom of the surface. Obviously, not all the particles cannot sediment or cannot settle down. That means some of the particles will be there who will not be able to settle down under the forces of gravity or electromagnetism. In those kind of cases, we will need to apply the process of coagulation, which is a chemical process, obviously, that involves the neutralization of the charges. Remember in the flow chart that I have shown in your class, the coagulation occurs when the negatively charged particles are there and some positively charged atoms will be added. Also, when the positive and negatively charged particles will come together, they will bond together and they will produce some new kind of thing that is known as the flocculation. That is the physical process again, but they do not involve the neutralization of the charges. That means when the neutralized charges will be there, they will come together and they will be added just because of the property of the atom. So these two processes can be simultaneously used in case of the water treatment as well as the wastewater treatment before or after the filtration or the sedimentation. Obviously, you can understand the sedimentation along with coagulation means when the sedimentation will occur, some of the particles will settle under gravity and some of the particles will not, which will be settle under the gravity force with the help of the coagulation. These are some of the examples, iron and aluminum salts. Obviously, alum salts that I mentioned in the class is that alum and salts, these are the things which will help to sediment the particles and to produce the coagulation. These are also few of the names. Obviously, you can easily understand from the names that they are actually alum, that is aluminum sulfate. So, polyaluminum chloride, which is also known as PAC or liquid alum, alum potash, everything obviously will actually soften the water. That means they will take out all the particles which cannot be held under gravity with the help of the coagulation. Now, there is another term, particles that cause turbidity. Turbidity means unclear water. They are generally negatively charged and they make it difficult to clump together because of the electrostatic repulsion. Now, this negative turbidity particles, which are in the negatively charged, will need to add some of the alums so that they will be neutralized and then they will accumulate to form the flocculation. Obviously, we will show you some of the pictures after that so that you can understand the flocculation process. Obviously, coagulation is affected by the coagulant use, its dose and mass. Obviously, we need to restrict the doses of the coagulation. Obviously, we need to think about the pH and the initial turbidity of the water. So this process, you can see that first of all, there are impurities. They are actually moving in the water. After adding some of the coagulants, they will produce the neutralized charged particles, and they will be tapped at to settle at the bottom. In most of the cases, in conventional purification system, we used to do this kind of things, as the coagulation, sedimentation, all the things will be done simultaneously. Obviously, you can see what actually happens in case of the coagulation and flocculation. The component is producing turbidity are actually moving. When the alarm will be added, they will come to the neutralized position. That means from negatively charged particles, they will be neutralized charged particles. Then they will come together to form bigger size particles, which is the process is known as the flocculation, and then they will settle under the forces of the gravity. Coagulation, flocculation, sedimentation process in wastewater and water treatment is very significant. Obviously, we have this kind of instrument in our own laboratory. Obviously, we cannot remove all the particles from the wastewater and wastewater through all these processes. Obviously, 90% of the suspended matter will be removed from the wastewater or water. Some particles like dust, earth particles, eggs of the fish, they will produce the floc, and they will settle down at the bottom of the sedimentation tank. Obviously, we know that for the sedimentation process, we need to wait for at least 8 hours, and we may need to wait for 12 to 24 hours so the sedimentation process can be completed. This is the picture clarification water treatment. It was taken up by one of the companies from South Africa, and they have this kind of unit. Obviously, you can see the blades over there. They will when they will be coming into the picture when the calculation will occur. And this is a kind of a picture you can see in our laboratory also. Some blades are there to mix all the particles along with the alum, and after that, the water will be going into the sedimentation chamber. Obviously, all the fans are not having the same speed. The speed ranges from high to low, and you can see that the raw water will be coming. The alums will be added in the flash mix. Then the water will be coming into the flocculation basin, and after the mixing process is done, it will be going to the sedimentation chamber, where all the sediments will be done, or all the sediments will be collected for 10 to 12 hours, or 20, 12 to 24 hours even if you need that. Then they will be coming down so that the water can be purified. So I hope I have cleared all your doubts for this particular thing. Obviously, I'll be sending you the notes later on so that you can easily understand the process along with this video.